Hello, math students. Welcome back to our module on linear equations. This is lesson 20, and it is called Every Line is a Graph of a Linear Equation. The goal that I want you to think about in this lesson is today we will continue working with standard form and slope-intercept form of linear equations. The question that I want you to think about in this lesson is, what parts of slope-intercept form are the same as parts of standard form? All right, so in the things to know section, I have given you a graph, and with this graph, I would like you to determine the linear equation that names the line. Okay, and so it says, write an equation for the line in slope-intercept form. Now transcribe the slope-intercept form into standard form. Those are the two requirements that I'm asking you to do with this graph. So one of the things that we remember how to do this with is that if you locate the M and the B, then you can go from there to figure out what would be the graph itself shown in the picture. So I'm looking at this graph right here, and I noticed that my B from this graph, remembering that the B is where the line passes the x-axis. This is the x-axis one more time, and I noticed that the line crossed right there. So in order to find the B, I have figured out that my x value is 0 and my y value is sitting at, and notice this graph says 2, so it's actually sitting at 1 because everything is increasing by a half, and you have to be careful because reading your graph is very important. Since this line up here represents 2, then that means this line right here would be representing 1, and it's hard for you to see, so let me dial it in a little bit so that you can see what I'm talking about. So you notice on the graph, this is a 2, this is a 0, this is a negative 2. So this graph is counting by 2's. So I know that that would be a 1. And then the second thing is that I have to figure out is my M. And in order to determine my M, I have to talk about what the line is actually doing. So if I go down to here and down to here, that down one time is a half, and another time makes it a whole. So that would be down 1, so I'm going down 1, and then I have to move to the right. That would be a half, that would be 1, that would be a half, that would be 2, that would be half, that would be a 3. So that means that I'm actually moving to the right 3 spaces, and so now I know what my slope is. So my B is still 1, but my slope, if I transcribe that into actual numbers, down 1 means a negative 1, and then to the right 3 would be to the right 3. So this is my slope right here. And you can tell that because if you look at my line is moving down as we go from left to right. So that means that I have negative slope. So now, kiddos, I have all of the information that I need to write it in slope-intercept form. Slope-intercept form, if you need to be reminded, is y equals mx plus b. And so I will write y equals, my slope is negative 1 over 3, because I go down 1 and to the right 3, x plus my b was 1. So now I have written this linear equation as y equals negative 1 third x plus 1. So now that I have done that, I have to take the next step that we've learned how to do, and I need to transcribe it into standard form. So we need to work backwards like we have been working the other way a lot. So now our job is to learn how to go backwards. So if you recall, the steps of taking standard form into slope-intercept form is that you're trying to get y by itself. Well, now we're trying to get the b by itself. So in order to do that, you just work backwards. So I have y equals negative 1/3 x plus 1. And if you remember this, we know that standard form is ax plus by equals c. So if we're looking at this, we know that the plus 1 is my c. So I need to be reminded of that. So this guy right here is my c. Okay? Then if I'm looking at this equation, then I know that this guy right here would be the AX group, and this guy over here would be the BY group. So what I'm trying to do is I'm trying to get the C by itself in order to go to standard form. Well, right now, this C value is being attached by a negative 1/3 X. So in order to get rid of the negative 1/3 x, what I have to do is I have to add it to both sides to get rid of it. So I'm going to take 1/3 x and add it to both sides. That's creating a zero pair. What you do to one side, you have to do to the other. And so now, if I do that, what I see is I have 1/3 x plus 1y, or y, equals 1. And now I'm almost done, because if I wanted to get it so that I don't have this as a fraction, then what I could do is I could take this whole thing and I can multiply it by 3, because when I do that, if I multiply this by 3 over 1, then that will get rid of the denominator here. But what you do to one thing, you have to do to all involved. So I'm going to multiply it to the whole piece, right? So I take 3 over 1 times 1 over 3x plus 3 times y equals 3 times 1. And in doing so, I would get 3/3, which is 1x. So I have 1x plus 3 times y equals 3y equals, and 3 times 1 is 3. So this right here would be an ultimate standard form, because remember, standard form is ax, 1x, plus by plus 3y equals c. And the c for this one would be 3, because we had to get rid of that fractional form. So that's why it transformed from a 1 to a 3, because we had to get rid of that denominator. And so you've learned the rule: in order to get the denominator, you have to multiply everything by the denominator to get rid of it. And so that's what we have. Okay? So that's kind of cool, taking this and turning it into this. Now, some of you might be skeptical and be going, I don't know if I really believe that. We can prove it again if you would like by going the other way. So doing that really quick, taking this, 1x plus 3y equals 3, and turning it into slope-intercept form. So remember, I'm going to subtract 1x from both sides. So I have that. I'm left with 3y equals negative 1x plus 3. In order to get the y by itself, divide everything by 3. And so I have 3 divided by 3 is 1. 1 times y is y equals a negative 1/3 x plus 3 divided by 3 is 1. And so now you have proven that this is the same as this. And so yes, this is standard form and this is slope-intercept form. You've just proven it. Okay? So that's really kind of cool. If you go back up to our goal, today we will continue working with standard form and slope-intercept form of linear equations. I now have taught you how to look at a graph and turn it into slope-intercept form, and then take slope-intercept form and turn it into standard form. And boys and girls, you're probably thinking, why do I need to know how to do this? The reason you need to know how to do this is because you never know what form is going to be presented to you, and you have to be able to work with it. So I'm trying to give you all the tools to be successful, to know what form it is. Standard form, slope-intercept form, a graph itself. You need to be confident with all three of them so that you can determine the information that's being shared. Okay? What parts of slope-intercept form are the same as parts of standard form? Definitely, I would say the parts that are the same is the values for A, B, and C. A, B, and C will always be the same as long as you take the steps to show everything that you need to do to transform one into the other. Okay? All right, kiddos, that's all I have for you in today's lesson. Talk to you soon. Bye.